popular question on SL exams in terms of this topic. So you've already attempted this on page 8 of question 5. So in lesson 1, remember we investigated like the binomial theorem, you discovered it yourself, and there was a question at the bottom of page 8 asking you just to find one term only, like the 5th term or the 3rd term or the x squared term. So these are more popular questions on the SL papers than lesson 3 was. Why do you think that might be the case? Why is it in the examiner's interest to ask for just one term?
Because it's also something to mark.
Less effort for them to mark, yep. Less time for them to mark. So it's super popular. In your topic assignment, you'll find stacks of them. So it's less effort for the examiner to mark.
What's less effort?
Just to find one term in the binomial expansion,
okay,
rather than the entire expansion. So for the examiner to mark. So expect this to be a really popular topic and anyway, just if you can find one term in the expansion, you've proven that you could probably have found all of them anyway. So it just means it's quick and easy for them to mark. Maybe saves you time too, because finding one term is maybe a bit less effort than finding all the terms.
Because we're having a quiz next week, does that mean that we'll have a test in 2 weeks?
Oh, there's no test date set yet, but I started to think, okay, better start doing mini tests now, just in case the test suddenly gets set.
Has anyone just look up for my shop?
So they're the little mini test ones. Okay, so find the x cubed term in the following. Different approaches to this. So some of you might look at that and go, oh, I know it's going to be the 4th one along. I know it's going to be the 3rd one along. If I just do that, I kind of make mistakes. So my little strategy to avoid me making these mistakes is I try to think, okay, in this expansion, what would be in the first term, what would be the exponent on the x? 5, yeah. Yeah, so I'm just kind of, in terms of x5, like, you know, x5, what would be on the second term, what would be the exponent on x? x4, 3, x2, x1, and so on, like, you know, to x0, that kind of thing. We want the x cubed term. So I do this to sort of work out, okay, where's it going to be? It's going to be there. And in terms of what is the NCR going to be? So the NCR, I would say just listen and suspend any understanding at this point. NCR, like it's really hard to explain from scratch. But if you can take in anything from today's lesson, Krista, you're doing very good. So 5C0. So and I do this because to remind me that the first one is 5, 0. So the second one, the coefficient would have been 5, 1. And the third one along is 5, 2. Because if I just look and think, oh, it's a 3rd term along, I sometimes by accident think that it's 5, 3. But doing it this way stops me and makes me actually think, hang on, it's 5, 0, 5, 1, 5, 2. Yes, oh wait.
It's 5, 4, 0, 2, 1, 4.
It's that, it's always that. Good point. Yeah, I know it is confusing. Sometimes there's things where you add one, sometimes there's things when you subtract one. And yeah, that's a very good point. But in this case, no, it does start with 5. And then, because it makes sense, because if you kept going along, you're going to get, to prove that, do you? 5, 3, 5, 4, and then the x0 term will be 5, 5. It's going to end, it always ends on 5, 5. Starts with 5, 0, ends on 5, 5, which means there's going to be 6 in total. In the whole expansion, there would be 6 terms. Yeah, that's a very good point. So if you ever you're in doubt, hang on, should I put a 6 here or a 4 there? You can start to write them all out and realize, yep, that fills the pattern. So the x3 term, I just start to do the first one until I get to x3, and then I start to think, what would it be? It'll be 5, 2. And this is a way of, like you could, eventually you might just look at it and realize what it is, but this is a strategy in exams for avoiding making a mistake, because you might have remembered something wrong. So we're just going to be using 5, 2. So the number from Pascal's triangle will be 5C2. So I start to write out. So it's going to be 5, 2. And as you can guess, it's going to be the first term raised to the power of 3, because that's going to generate x cubed. So the first term is going to be, in red, first term will be x cubed. And the second term will be negative 3, do it in green maybe. What must the exponent be on the negative 3? Because these two must add up to that one. 2, yeah. So you can think of that as being 3 is the same as like saying n minus r, because remember that n, that's r. N minus r, this one is like r, isn't it? Because the general form of that is nr. Remember that from the gorgeous formula kind of thing. So nr, so in a way that's like n, that's r, so this must be n minus r, and that one must be r. If ever you're in doubt, that's another way to look at it. Because we know it had to be an x cubed, so that's why we knew that one had to be 3. This could be done with calculator. So if it was with calculator, I would just go alpha, f2, and do ncr, 5c2. If it was without calculator, let's just try 1 or 2 without calculator, just to practice using that gorgeous formula. Quite often, this is more popularly going to be a calculator question, and you would just go straight to working out what 5c2 equals on the calculator. There's, again, in case we ever forget how to use that nice formula, we can practice it here. So remember, the nice gorgeous formula was n over r equals n over r equals what goes on the top? Good. Over just n minus r factorial. And that's in the formula booklet. Something goes weird on the board whenever it's at a certain point. I don't know why those divots happen. N factorial over r factorial, n minus r in brackets factorial. So let's try doing that with this blue baby here. So what would be on the denominator, the numerator, sorry? 5, good, yep, so just write 5 factorial if you want. Over r factorial would be 2 factorial. And n minus r is 5 subtract 2. 3 factorial, yeah, 5 subtract 2, yeah. I'm running out of space, so I'll just say 5 factorial, 2 factorial, 3 factorial. X cubed is still there. What's negative 3 all squared? 9.
Can I get some paper towels?
Yeah, that's a good idea. Have it now before any electronics get destroyed. And maybe here, just in small writing, let's try writing out the factorials and cancel down. So most of the time, as I said, most of the time this would be with calc, and you'll just do 5c2 on the calculator. We'll just do 1 or 2 non-calc, just so you don't forget how to do it non-calc. So you would write out the pain tool. 5 times 4 times 3 times 2 times 1 over, that would be this one in purple, 2 factorial, 2 times 1, 3 factorial, yeah, all that stuff, yeah, exactly, so times 3 times 2 times 1, and then you've still got your x cubed, and your 9 there, but you could change it to 9 cubed if you want. Or stuff funny again, very annoying. Maybe I'll extend the page. And then what cancels down? Heaps of stuff. 1 cancels, 2 cancels, 3 cancels. Forgotten how to do this. At the moment, you could think of it as just 20 over 2. That's easy enough to do in your head. If you wanted to, you could also cancel 4 and 2 and rewrite it as 2 if you wanted to, if the numbers were still big and awkward. But you don't need to. It's easy to work out.
So I can go up.
Yeah. So the board's getting all small in the middle. I don't know why. I think it's a problem in the software. You're running out of space, maybe just move it down there. So what's 5 times 4 over 2 times 1? 10, yeah, it's 20 over 2, so it's 10. 10 x cubed, don't forget multiplied by 9. So that's why I keep bringing these red and green things down, because otherwise you can easily forget and think, oh, my answer's 10, great. But if you don't bring those things down, you can forget that you're not quite there yet. Strangely enough, I wrote my answer as 10x cubed because I didn't bring it down. So what should the answer be instead? 90x cubed. Good. So it should be 90x cubed. So in total, 90x cubed. So if the question's just asking for the x cubed term, then you found it. Okay. Just double check, did the question ask for the x cubed term or did it ask for just the coefficient? It wanted the whole term, yep, so we're done. If it wanted the coefficient, what should our answer be written as? 90, exactly. So be aware, like in questions I'll flip between find the x cubed term to finding the coefficient. So just be aware of that kind of stuff. And then we're going there's lots and lots of examples. And again, it's just find the x cubed term, just to keep it up. But we're starting with x to the power of 8 this time. So it's not going to be the third one along necessarily. So what would be, so notice it's x, then y. What would be the exponent of x on the first term? 8, it's going to be an x to the 8. Don't worry about what the coefficient is at this point if you want. Then the next one along will be 7, 6. We need the cube term. 5, 4, 3. So it's going to be this little baby here. And if it helps again, what will be the brackety, the NCR on the first one? 8, 0, yep. Next one's going to be 8, 1. If you can't be bothered writing them all in, you can try doing dot, dot, dot. So 0, 1, 2, 3, 4, 5. The fifth one along. So what you want is, this is a strategy I use to avoid me getting this number wrong. I personally find it helpful. If you end up devising a different strategy, it's fine. So long as what it does is stops you from, by accident, thinking it's 8, 4 or 8, 3 or something like that. So I just write them out, 8, 6, 7, 5, 4, 3, and then realize, okay, first one's 8, 0, next one's 8, 1, 2, 3, 4, 5, 8, 5. Because it's really important to make sure you get that blue bracket right, your NCR. Then we start to write it out, what it would be. So it would be 8, 5. They love seeing this. They love seeing this at the beginning. Love your working out. The examiners are really big on it. First term, now we do need to factor in the 2, and it's going to be x cubed, isn't it? So what will be the exponent on the first term? It's got to be a 3. And so the second term is positive 5y. What's the exponent got to be on that one? 5, yeah, how did you get 5?
3 plus 5 equals 8.
Yeah, 3 plus 5 has to equal 8. Yep, correct. So think of that 8, that's n, that's r. So this is n minus r. In red, in green is just r. At least that's another way that might help you remember. And then we've just got to work that out. As I said, this would normally be done on the calculator. I'll just do this one more one without calc, and then from now on we'll start to do that part with calc. That's awful. Yeah.
How come you didn't do 2x 8, 5y 8?
We just don't. I can actually explain that to you quickly. So it's because they want the x cubed term.
Okay.
Yeah, so we need to...
So you can break it up. So you because you could break it up. So if you had like 12, you would do 3 and 9.
Yeah, exactly. Yeah, that's totally it. Yeah. Yeah, that makes sense. And then 8, 5. So let's do a painful by hand version. You've got hopefully a bit more space this time. 8 factorial. So it would be 8 factorial. Maybe you want to write this out first. 8 factorial over. What's r? 5. Yep. And n minus r. That's 5. Just kind of doing it like that. We can work out what is this. What's 2x times 2x times 2x? Is it 2x cubed?
Yeah.
You might think it is.
That's
Yeah, how did you get 8x cubed?
2 cubed
Yeah, 2 cubed as well. So that's something to be wary of. 2 cubed is 8. X cubed is x cubed, of course. So it's 8x cubed. Put brackets on it if you want. What's 5y to the power of 5? That's pretty horrible.
3,125 y 5.
How did I know? How did I do that? Hang on, everything is right?
I don't know what you used to.
I think I had. Yep, I think what I did, because I did these really rushed yesterday, so I think I made a bit of it. This is right, isn't it?
Yeah.
1, 2, 3, 4, 5, 6. Okay. Yeah, we can do it later. So that would be hard to do without calc. You do, so to be honest, this one would be with calc, but we can still try this part with calc. 5y, sorry, what was it again?
3,125.
2,000,
3,000.
3,000.
125.
Yeah. Whoops, I didn't close my bracket yet. And then 3125 y5. Full brackets if you want. Just showing that basically we're multiplying them all. I'm trying to avoid using x's because they can get easily mistaken. for multiplied sines for x's. And now let's try doing this painfully by hand for the last time.
I like it by hand. I don't know calc because my calculator's just stupid.
All over.
Mine's all basically the same.
So what's nice is loads of it does cancel down, which is good. So we've got 3 factorial, no, 5 factorial, isn't it? Yeah, 8 5. I keep putting the wrong ones in the wrong spot, don't I? 5 times 4 times 3 times 2 times 1. Over. 3 factorial times 3 times 2 times 1. Great. And then cancel down. Down. Or you could have cancelled from here instead if you wanted 4, 4, 5. So you could work out 8 times 7 times 6 and divide it by 3 times 2 times 1. Or you could start to break it down. Maybe I'll break it down. 8 over 2, what does that cancel down to? 4, yeah. So you can cancel down 8 and 2 and rename that 4. 6 and 3, what does that break down to?
2.
2, yeah. So if it was by hand, that might be a good strategy. Then you've just got to work out 4 times 7 times 2.
Much easier.
56, good. So not my answer right then. What colour do I do that in? Blue. 56. So that'll break down to 56. In reality, most likely you'll be asked to do that with calculator. So you would just do NCR 8C5. And now we've just got to work out what's 8 times 3125. And I did mine wrong because I did 5 here instead. 8 times 3125 is. Oh, anyone with a calculator? 25,000? Oh, nice. Okay, cool. That's good. And then it's x squared, x cubed, y5, yeah. So x cubed, y5. Just kind of breaking it down a lot here, just so you can see how it's all done. If you want to do it in shorter steps, you can. Then you just got to work out 56 times that, and then you've got the term.
1.4 million.
1.4. With
1,115,000.
Okay, yeah, so there's not another 4 or anything. X cubed y5. So my boo-boo was, what did I do? My boo-boo, I did something wrong at the beginning. I did 8.3. That's what messed me up. I didn't do 8.5, I did 8.3. Oh! Now I know why I did, but that's fine. It's all because, yes. Oh! Find the x cubed term in the following. So I was looking at the wrong question. Oh, it's fine. My initial answer was okay.
It should be 8. I mean, 8, yeah.
X minus 3, 5, yeah. But, oh, that's weird. On my printout, I have an extra instruction that says find x5, y cubed. But we'll just, that's right. So this one follows through from the above instruction, that's fine. I just don't recall ever deciding to erase it. Yours doesn't have that line, does it?
No.
Okay. I must have decided to just go, okay, ditch that, just make it the x cubed term. Weird. So my answer matched what I had to begin with. It's okay now. Life's good. Life's good. So I just want the x cubed term. We don't need to. That's weird. I just remember erasing that line. Strange. Okay. So we just don't want, they want the whole term, not the coefficient. So we're done.
And we
Big
are
awkward numbers.
clear.
And now we'll start to, instead of doing this one by hand, using the gorgeous formula, we'll start to use NCR. So you're going to be using a calculator, NCR,
Well,
button a lot. And where that is on your calculator, Krista, I don't know.
This lady stuck there and shade at my calculator.
It's probably there. It might even be easier to find on yours.
See.
In case you want to practice on one of these, oh, this one's finished, and this one's just run out of batteries. so
NCR, you
use this
said
one.
Hazel is fine.
Yeah, NCR. Yep, NCR.
Where is it going to go? Math?
I'm really lost.
I don't have a math.
They're gonna help you.
It's so strange that I erased it. Okay. I'm still thrown by that.
Thanks, me pass it back on to the portfolio.
Now we're on to page 17. So now we're going to use our calculator to find an NCR, as I said. There's really, and then they're getting a bit more challenging. Yeah, they're getting more challenging because see, you've got an x and you've got an x squared. So I've got there's a particular strategy that you can use to find out which term is it. So when it's just got a single x at the beginning, like if it was x plus 3 or 3x minus 1, it's easy to work out where along in the sequence are you going to get the x seventh term. Okay, but yeah, this pace, oh no, it's fine, it's just asking for the 7th term, that's fine. We just need the 7th term. It's not asking us for the x 6th term or the x 7th term. That's the next question. So here it's just the 7th term, that's easy enough. So in terms of your coefficient, if you're not sure where the 7th term is going to be, so notice it's out of 14. So what would be the NCR for the first one? It'll be 14. 0. Don't forget the first one starts with 0. So you could, if you're not sure, just write it out till you get to the 7th. This next one. You might start to see a pattern and realise what it is already, but it can be easy in exams to get them mixed up. So if you're in doubt, you can kind of like write it out from scratch like this. 0, 1, 2, 3, 4. 5. 6. 7.
So it's just if we over and subtract 1.
Yeah, yours might be written in a different way. So which one's the 7th one along? Let's see. I've kind of just written
14, 6.
14, 6, yeah, probably, yeah. 1, 2, 3, 4, 5, 6, 7, yep. So that's what we're using. We're using NCR, it's 14, 6. So as I said, you might just start to see a pattern and realise what it is, but it can get mixed up in exams. So this is where you can start from scratch and just be a little bit more certain.
A safe way.
Yeah, it's a bit safer, yeah. A bit of a safer way to kind of get to the 7th term. So 7th term is the lovely little blue one. So it's 14, N is 14, R is 6. And we're going to use our calculator this time now to find it. So we're going to practice using our NCR button. What will be the coefficient on the first term if it's the 7th one along? So remember the first term, if it helps do this too. I'll do it in a different colour. So the first one, you're going to get x14, then you're going to get x13, because it's going to be descending powers of x for the first term. x13, x12, and so on. 11, 10, 9, 8. Would you agree that it's going to be to the power of 8? And what's another way that you could have realised it to the power of 8? Just looking at those two numbers.
14 subtract 6.
Yeah, 14 subtract 6, yeah. So again, like you can check it by doing it out by hand, like I did. You can also kind of check. It's going to be n minus r is going to be the exponent on the first one. That's a good little pattern to see. N minus r would be that exponent, just kind of proven to you by doing it like this. It's going to be NC8. So on our second term is negative, so I'm going to call it negative 4 over x squared. What would be the exponent on that one?
So now we're finding the 7th term.
Yeah.
So why is it at 8?
Yeah, that's a very good point. Because see, the first time is going to have x14. Well, this part's going to become x14. x13, 12, 11, 10, 9, 8.
Oh.
Yeah. Yeah, so that's a good point. So just by thinking, oh, it's a 7th term, it's going to be x7, that's the danger. So you could either like work it out manually to see if it makes sense, because it doesn't take long to do this manual thing I've done at the top. You can also see these two numbers. So another way as well to lease is the exponent will be that minus that on the first one. The exponent on the second one will just be the r. It'll be the 6. And 8 plus 6 is 14. You can double check it up. It's making sense now. So going really carefully. That's the way to go.
Can you send me the link? She found out my calculation.
You did, good. Okay. So if you want to write your little instructions, remember it's alpha, or whichever way you do it. You might go math probability. Alpha window, or some people call it F2, and you select NCR. So if you want to make a little reminder to yourself, that's how you do it. And that means, so on the side, what is 14/6?
That's fair.
It's actually my software, it's not the board.
That is fair.
Something's up with the software. 14/6. What does it equal?
3003.
But 3,000? Did you say?
And 3.
And 3, really? Okay. 3,003. 14 and 6.
No, you're up.
Yeah, so practicing it with calculator. So 3003, we can put here. Just replace the blue part with 3003. This is where we'll probably need calculator stuff. We'll work these purple and green terms out separately if you want, just to show that it can be done. What's 3 to the power of 8?
6,561.
Horrible, isn't it? 6,561. Don't forget the x8 as well, very important as well, because that can be easily dropped off. Interesting. Now we're doing -4 to the power of 6. Would you agree? A negative to an even power is always a positive, yeah. So if you want to, you can just go straight to thinking, okay, it's going to be positive. If not, you can put in -4 to the power of 6 and you'll find that it's positive anyway. But you would need to put it in brackets like that. If you put -4 to the power of 6, you'll get a negative. So just be wary of that.
So
What is -4 to the power of 6? Some awkward number? Yeah, that's right. It went away, cool. 4,096, and it's going to be over. What is it, Sarah? You're right? Yeah, x to the power of 12. Practicing our exponent laws. When you've got brackets like that, you multiply the exponents.
So when you add
When do you add exponents? When it's multiplied. X squared times x to the 4. That's when you multiply exponents. When it's brackets, it's like we call that an exponent of an exponent.
Okay.
Yeah, an exponent of an exponent. That's going to come up a lot, actually, in this topic. So this is a good review of exponent laws. Now, we're going to have a big, horrible number as our coefficient.
we are.
That blue one times the purple one times 4096.
Oh, I got an E plus number.
Yeah,
That's close.
80 something.
8.07021.857
E plus
And a 0, is it? Yeah. So the board's funny. That's 80702189570.
I didn't get that. I got 8.
I had a slightly different answer because I misread my calculator. Instead of 3003, I saw 3000.
Yeah.
Oh, that's because it's times 10 to the power of something.
Wait, what does this E thing mean?
It's a standard form. Did it give you your answer in standard form?
that times 10 to the power of 10.
Oh, like 8 point something
Yeah.
times
Yeah.
10 to the power of 10. Exactly, yeah. I just went straight to
So
writing
what,
it
you
out.
just have to move decimal 10 times the other way?
Yeah, which I did.
So why don't they just do that? Go back.
10. Because your calculator screen can only show 9.
But even when I got that, I didn't get that. I got 80689. This is just 8. Never mind. Never mind.
I got a different answer because I by accident I wrote down 3000 instead of 3003. But you all confirmed it was 3003. So you guys must have been right.
So even if I got a slightly different number, it's okay, right?
You must have typed in a number wrong.
I said, oh yeah, I did. I put 660. That's 6,
Yeah.
5, 6.
And same thing, I typed in 3000. Yeah, let's see. If it wanted the coefficient, thank you. It wants the 7th term. So we've got to confirm that we've got x. What's the exponent on x going to be? So we could, if you realize that over that, what it's going to be, it's fine. But you could also, to prove it, go x8 over x12.
Wait, why?
Did it say 189?
You see that? Those two?
Oh,
Yeah, so we've multiplied these numbers, but yeah, good question. Because that's like that over that,
Okay.
which
Wait,
will
what?
be overall.
Wait, how did you do that?
It says not to simplify.
That one? Or that?
I was just thinking.
So how come you didn't do
Oh, did it? Yeah, sorry, yeah. So I've taken it further.
X.
So Lisa's patiently been watching, going, I didn't ask us to simplify. So to be honest, that's the answer.
Wait, but if it did ask us to simplify?
Yeah, then we have to do this, yeah. Most of the time it's going to
Wait,
ask.
okay, wouldn't it be
It's
that
just the
little
answer.
number over X12?
Yeah, it will be over
The
at
final
12.
answer?
The first one?
And then you can cancel it out, cancel them out.
Which becomes
X and negative 4.
x to the negative 4. Yep, so you could write x to the negative 4, or you can write that thing over x to the 4.
Wait.
Which is what they
Yeah,
might,
yeah,
which
yeah.
is what they'll tend to do in the
So
book.
Miss Maloney, which is the final answer? Like, which one's the non-simplified?
I got my tongue.
Oh, the non-simplified
Oh,
answer
wow.
is that.
Wow.
Did I write your tongue way back there?
If you want, you can, if you do write that, you can cross that out. Sorry about that. The non-simplified was just the first line.
I thought.
I just went too far. 807. Sorry, the board is so.
I just feel so nauseous. That's so weird. I feel nauseous.
Wait, Paige, how much did you do?
All over.
Go to math. Or no, go to the
And you. Wrong math.
Yeah.
Then F6.
F6.
This is the simplified answer.
3. Wait, let me clear. Okay, so F6.
And now I know why the question asked for the unsimplified. It's because your calculator only shows 9 digits, which meant finding that number is really hard. Most of the time, the number's going to be shorter. It'll be a big number, but it'll be small enough that you can see it on your calculator display. So that happens to be the simplified answer. So I crossed out simplify, you don't simplify. If it was do not simplify, it would have been that.
But if it is 14 over 6 and 1003.
Yeah. Yeah, but that would have been
Oh,
just, yeah.
sorry.
Oh yeah, because I did it, but then I wrote a note to myself, this is the unsimplified answer, but if we did simplify it, I worked it out because I was thinking, I bet one of you was going to ask what would it be, simplified.
Oh.
So that's why I worked it out.
And then what?
Pretty painful, pretty painful. Normally the number's going to be a big number, but it'll be not as many digits as that.
I think Paige deserves some candy. She figured it out.
You found out how to do it?
Yeah.
Oh, good.
No, not me, Paige did. Yay.
You're good at working out the calculators. Here we go. In the expansion of this thingy, let's keep going. We've still got like 20 minutes. Let's try to knock some more down. Owen, thanks. Okay, so in this expansion, we've got x squared and then x here. So again, it's a bit trickier. Find the coefficient of x to the power of 6. And there's a special strategy I'm going to show you that does that. And this comes up a lot in the topic assignment, this one. So the strategy might be weird to begin with, but you're going to do it so many times in the topic assignment.
This is
that
a new
it's going to
strategy.
become, yeah. And it's because this one was fine. It just told us find the 7th term. So we just had to count along 7th term. But here it's telling us find the x to the power of 6 term. And there's an x here and an x here. So there's going to be all this cancelling out going on as you kind of expand. So there's a strategy for realizing what the n and the r are going to be to get the 6th term, which I'm about to do now. And then the constant term is when the x's would have cancelled out. So what would be the exponent on x for the constant term, out of interest?
So the x's would have cancelled out.
So the exponent, yeah, the exponent on this one will be 6. For the constant term, what would be the exponent on x? 2? Because there'll be no x anymore. 0, yeah, because anything to the power of 0 is 1. So the constant term would mean when the exponent, yeah. Because constant, you realise constant means there's no x in it anymore. Like, yeah, constant term, you might not have realised what constant term means. Constant term means a term where there's no variable with it, like 6 or 7. So at some point in this expansion,
Wait, so
there's
there's
going to
no
be a
x, so
constant
there's
term.
no variable.
No variable. In this case, the variable is
So
x,
no
x.
number.
So x is the variable.
Just a number.
Will the constant term always be x?
The number is the coefficient, x is the variable. So no variable means no x.
No.
Okay.
For the constant term will always be a number. Just a number with no x. Therefore, it means the exponent on the x must be 0, because x to the 0 is cancelled out to 1.
Okay.
Yeah. Yeah, because at some point later, you're going to have to bear in mind
Wait.
what is the exponent on x. What's
So
the
the-
exponent on x?
So the way to get rid of x is make it 0 because then equals 1.
And there's a strategy for working out what is the n and the r, like, you know, the n, the r. What would the n and the r be that gets you there? You can do a bit of trial and error. That's no problem with that, so long as you get the right answer. But there's a particular strategy that takes you right there, and it involves a lot of exponent law thinking as well. Here we go. So as I said, I wrote here, could experiment or could use this method. We know what n is actually. It's what r is. What's our n? Remember, like from, by n I mean from that thing. What's our n? It's 12, yeah. So you might just want to make a note that n is 12. And that came from there. That thing tells us the n. It's the r that we are going to solve for.
Oh my gosh.
So we know that it's 12, but we have a mystery r. Ooh. If it was just x here, it'd be no problem. If there was just x and a number, it's easy because you could just work out first one's going to be x12, then x11, then x10, x9. But it's not. There's kind of awkward things going on here. The first term you can see is x squared, and its mystery exponent. Can you remember, like from the previous two ones, that number always happened to be that minus that.
So,
Like 12 minus r. And the exponent on the second term, 4 over x, was always, yeah, r. Remember from the previous examples?
yes, I got a little formula.
Yeah, that's right, yeah.
Coming together.
Yeah, remember like when you did 14 and 8 gave you 6, and then 6 was there, that kind of thing. 12 and r. So this is how you can solve for a mystery r. We need to do a little bit of expanding. At the moment, whoops, I'm not going to do that. At the moment we don't know what r is, so just leave this as 12r. So we can do a bit of exponent law expanding here. If we expanded the exponents, remember it's an exponent of an exponent. So what do you do to these two? These multiply.
So it
Good.
becomes 24 subtract 2r.
Good, yeah. 2 times 12, 24. And yeah, good. It's good that you realise subtract 2r. That's the main error. Some people do 24 minus r. So like Krista said, it's 24 minus 2r. So keep be wary of that. That's something to be wary of. What will be the exponents on this green thing? Ah.
Over x over x.
Are you yawning or are you saying the answer? Good, yeah.
Okay.
That, because that's like 1 and 1.
Hey.
So exponent on there, exponent on there. That's an r there. Okay. Now a little bit of exponent law. Same thing, we still don't know what r is, so let's just go 12r. So our coefficient will be 4 to the r, because there's no other numbers, is there? So 4 to the r, this would be another little number there. In terms of our x, I'll do x in purple now. X overall, if you did x to the 24 minus 2r, divide by x to the r, what do you do to the exponents when you divide?
You just
Subtract. So what's 24 minus 2r minus r?
24 subtract r.
Close.
I wish it was just
24 minus 2r minus r? Subtract. Minus 3r, yeah.
Yeah, back.
So that all came from, so I just kind of realised, okay, this is a number,
Wait,
let's
we
get
are
it out of the
now?
way and just move it there.
Oh, because it becomes negative. Yeah, yeah.
So here, this is 4 to the r, is just going to be a number, so I've just shoved it here, because they're both going to be numbers.
How did she get 3R?
Yeah. Yeah. So if you want to, if you happen to have a bit of space, you might want to explain that that kind of thing is x to the 24 minus 2r, all divided by x to the r. So we subtracted the exponent. And that exponent minus that exponent gives us 24 minus 3r. This, you end up doing this 100 times in the topic.
Wait, I don't understand what you did.
Wait,
Yeah,
I'm really confused.
Yeah,
So
that's
is it
confusing.
x to the power of 24 minus 2r times by 4r?
Yep,
Would
and
it
the
be
4r just
over
pops here.
everything over x to the r?
See, exponent laws only apply when you've got the same base.
No,
So
but I'm saying, what
I'm only using that exponent law for these two. This is just a number.
I
This
think
is
what
just a
this
number.
was-
So I'll pop the numbers together. So see, the numbers are this and this are just going to be a number.
Yeah, okay.
And these have the same base, so we can apply an exponent law to them because the base is x.
But is that still gonna be x over x?
So because it's 4 hours.
But then isn't
So you agree?
the x24 minus
use the
2r still over x to the r.
You could.
It was.
I kind of got
Just
lazy.
skip that step.
Yeah, I think
Maybe
it's
they
that's
write
what
that stuff
confuses
out.
me.
Over.
That's why I miss the learning.
Okay. So it's kind of like that. So it's like saying that over that.
No, but
So
how
why
come?
is it over?
Yeah.
Why is it over the 4r? I mean, under the 4r.
How come you
Because
did?
4 is a different base to x. So there's no
But it's still
exponent
under
laws.
it.
But why did you just take it out?
Yeah.
She
Why do you just
multiplied
take
it.
it
I
out?
popped it here instead. I popped that times that. I popped together. Just because they're going to be just numbers.
Oh, so you just can you do that?
Yeah, because like
Yeah.
we put x and if the ones are over 1, you would multiply numerators.
Exactly. So how come you can multiply x to the power of 24 subtract 2 for times 4r and then
Okay.
1 over x?
Yes, I did.
They're still times together.
But isn't the 4r still over the x to the r?
Yes, it all is
Yeah.
now.
But
But it's not.
But we've factored,
Yeah, it
this
is.
is gone now.
Oh, Miss Ruth, I understand
Yeah,
now.
yeah, it's gone, yeah.
Oh.
So this little,
Oh.
so this little thing, if you've got any space and you want to write it on the side, you can, but just be aware there's another question under there.
So if you put over 1, it makes more sense.
Yeah, if you want to do that kind of stuff, yeah, maybe you want to write it over 1. That's a good idea. Would that help? To write
So
that
you
red thing
just
over 1.
multiply.
Okay, what?
The board just stopped. Yeah. I'll just quickly save this. Looks like the board's frozen. Yeah, and especially the first time you do this, it's going to be really weird. Okay. So this is just frozen again, sorry. I'm just going to have to close that. So yeah, the red thing, maybe write it over. This is recording good. Kieza's going to love this. I told her you're missing a really intense lesson. That's all recorded.
If I would have missed, I would have seen farther behind.
We're about here, are we? We're on there probably.
So on me,
And as I said, we're going to be doing this quite a few times, and so it's going to get better the more you do it. The first time is going to be a freak out. Yeah, so that's a good point. Like, was it Krista or Calvina? Did you say the red thing? Maybe if it helps, write that as a
That was
fraction over
Krista.
one.
I
Krista,
said
yeah.
to you before you said
Krista. So that becomes x to the 24 minus 2r minus r, which is how you got x to the 24 minus 3r. I'm just writing so big that I know I'm going to run out of space.
Wait, what?
But you can totally do those on the side.
Grace is still confused. Just take a minute.
Is it the fraction you did?
Yeah.
So would it help if I wrote this as a fraction over 1?
Yes.
No, I don't want to do that.
What did you do?
Why
Why don't you want to do that?
It's alright if I do it like this, but you know, with that board eraser, it's just going to erase all the stuff outside of
I
it.
got the juice that was so
There you go. Now it's good. So that's better. Yeah, let's do it. 24 minus 2r. There you go. Is that better? It's
Yeah.
kind of like not a very nice. I should have put it a bit lower down.
So then it would be.
I did it lower. Oh, over 1. That's a bit better.
No, you wrote it bad.
So it's over x to the r, right?
Yes, it's all over x to the r. Correct, yeah. The whole thing's over x to the r. Good.
So nothing happens to 4 to the r, even though it's still being divided by x to the r.
Yeah.
That doesn't make sense.
Because it's only -3r because it has the same base load from x.
So, but nothing happens to 4 over r, even though it's still over x to the r. Does the x to the r just disappear?
It still being time. Yeah. Yeah, that's a goner. It's been absorbed by the exponent law. See that? See the exponent law? That over that? Became that.
Oh, I know what
Can
you're
you say
saying.
that?
So if you put the 4r in front of the x in black, then
Like that.
is that no like on top
Oh, on the top, yeah. So it's
Yeah,
still in
so
the
like why
numerator.
does nothing happen to it?
because of the and then put it in the answer. So it's just 4r. Nothing happens to it because
It doesn't have the same, it doesn't have x, so nothing can happen to it.
Yeah, exponent laws are when you've got the same base.
like it was 4r xr.
The base of this is 4. The base of that thing is 4.
But I
Whereas
thought
the
you
base
could
of
only,
these is x.
but you could only like cancel it. it applies to everything.
Yeah. It's almost like saying this rubbish times that rubbish. It's like saying those things. This whole thing is in a way like saying those things times those things. Put together. So it's like saying these things times by those things.
Okay.
It's very weird.
Yeah.
So just be aware, there's going to be a question here. I'll raise it off when we get to the question, but I'll leave it there for now. What was I going with that? So now, awesome. So what's the exponent on x meant to be?
Ooh, x to the power of 6.
6, yep. And we've got a little expression for that. So we can solve for r. If that's meant to be 6, what must r be?
That's meant to be 6. 24 subtract 3 times something is equal to 6. Yeah,
Okay.
so that has to be 6.
Okay, so you want to do this maybe on the side, yes? 24 minus 3r equals 6. So I just go 24. Oh no, it's 14 thing. Is it 6?
Yeah,
Probably. Oh yeah, you're right.
There's a couple of numbers.
Yeah, so it's just regular linear solving. So you could go 24 minus that is 18 equals 3r. So r equals 6. So if it helps you, just put this in a little box, because that's a little thing you've done on the side. I tend to, on my exams, I tend to do it off on the side, but you've got a question here, which is making it annoying. Otherwise I would have done it off on the side. So you've worked out r, which is awesome. So now we're going to just put 12 6, 4 to the 6, and then we're going to sub in this. We know that's going to be 6 anyway, because it's meant to be to the power of 6, but if you're in doubt, you can work it out. 24 minus 3 times 6 is 24 minus 18, it is 68. And then we work out those numbers with our lovely calculators. So we know it's 12 6 now. 4 to the 6. Look it up because it's funny. 4 to the 6. And then 24 minus 3r. If r is 6, it's going to be
We forgot the r this time.
Yeah, so all of that business was to work out just what the r was.
We forgot to carry the r.
Yeah, so we've worked out that r is 6 now. So we're replacing r with 6. So see what was up here? Here is when r was subbed in. Now if we know r is 6, we're going to sub that into that. So now we can be careful. Like sometimes if you're like me, you might have a 12 and next thing you know you've written 14. Always just look up, have you followed through the right numbers? Because so much is going on in your brain right now. Always look through, have you followed through the right numbers? 12C6 with your little calculators, with your NCR button. What?
Ooh, 924.
924. Yeah, it's good to know how to do that. It's a good strategy. What's 4 times 6? No, 4 to the power of 6, sorry.
4,096.
Something like that, yeah. Yeah, 496. And the x6 is going to be that thing. And then you've got to work out that blue number times that green number for your final answer.
3,784,000. She reading this.
No, I love you. 704. And for Kieza's sake, that board's a bit messed up.
Kieza, hey girl.
Nicole's doing well. 3, 7, 8. So sister and I got the same number. So. Did it want the coefficient or did it want the whole term?
It wanted the coefficient.
So if you want, write it first, but then just be aware they want only the coefficient. So be careful, if you write the whole term, they might not give you the full mark, which would be really mean. But who wants? These are big numbers, so you want to look at your calculator really carefully. They're really big numbers and your brain gets scrambled. So be careful, just read it a few times and make sure, did you skip a digit? Did you repeat a digit? Canberra. Canberra. We say Canberra.
Yeah, she is right. She's right.
Okay, constant term. Do we have time to do it? Do you want to stay and do a quick constant term?
No.
There's like hundreds of these on your topic assignments, by the way.
Hundreds, so we're gonna have that.
So constant term, it's the same thing, but just be aware, the same formula, that R formula, you're going to set it equal to 0 though instead. So if 24 minus 3R is 0, that's going to find your R and you're going to sub it back in. It's going to be the same process. So you from here, you're just repeating here over here, except you're doing 24 minus 3R equals 0. So 24 equals 34.
If you would make it, can you go over this again and add
Yeah.
to the tomorrow?
Yup.
Just in case you don't make it. So see, for the next one, remember the exponent 0 when it's a constant term, it's x to the 0. So R is going to be 8 for the second one, and then you're going to do this, but with 8. R is 8. I need to give you the topic assignment so you can have a chance of even starting it.
No.
Oh, the topic assignment?
Yes. Here it is. I did it last night. It was loads of fun.
I bet.
It's very repetitive. It's like hundreds of facts. So just do it. So the topic assignment is like a whole stack of what we just did.
Oh, we're not like
Just do it with something erasable. Big with red, do it with something erasable. No worries. Because these are the kind of things where you want to get through it. Luckily you seem to have a lot of space. It's not something specific. So I've only done something like 16.
Okay.
Topic assignment has got lots of the very last thing I've
Thank you
done.
very much for your
Okay.
And there's been heaps of questions about this.
Oh, that was your question.
Good.